We are moving into my absolute favorite thing out of all of science, which is talking about elements and the periodic table. Today we're going to focus on what each box on the periodic table represents. What is the information that we can get from that? One recommendation that I would have for you in the next couple of weeks is to always have a periodic table somewhere close. So in another tab, you can just Google any periodic table should do. So elements from last unit were matter made of one type of atom. And if you remember, we cannot separate it by physical or chemical means. So it is as simple as we can get without doing like crazy nuclear stuff to it. And most elements are not found in nature by themselves. So as we talk through the next couple of lessons, I'm going to mention that a couple of times, that yes, this is an element, but you wouldn't find it in nature out by itself. Excuse me. So you already know that an atom is the smallest piece of matter that still has all the properties of an element. So that means that I can break down maybe the element beryllium down to one single atom, and it would have all the characteristics of beryllium. Now, I can get smaller than that. I can have protons and electrons and neutrons, which we're going to cover today. But when you're looking at an electron, you can't say, oh, that electron belongs to beryllium. So the atom is the smallest we can get and still find those properties. So speaking of subatomic particles, protons, neutrons, and electrons, we're going to focus on their individual characteristics. So we're going to treat protons and neutrons pretty much the same, because the only big difference between them is something that we already know from our electricity unit, that protons have a positive charge and neutrons have a neutral charge. But what we're going to focus on are the other things that we haven't covered. So first of all, they're both located in the nucleus. Now, every picture that you ever see of the nucleus of an atom is so wrong. This picture included. The nucleus is so tiny in comparison to the atom as a whole. So when we talk about the total volume, the space of an atom, protons and neutrons really don't factor in. And we're going to assign them a mass of 1 so that we can compare it to the mass of the electrons. So electrons are located in the space outside of the nucleus, and it's called the electron cloud. So it's all these different rings of space where the electrons spread out. So most of the atom's space or volume is taken up by the electrons. Now with mass, we assigned protons and neutrons a mass of 1. That's because electrons in comparison are almost 2,000 times smaller. So we really don't factor them in when we're talking about the mass of an atom, which we will be doing today. And I like to say that it's like weighing yourself and a hair falls off of your head. It's there, but it doesn't affect your weight. That's pretty much what an electron's doing as well. It's there, but we're just going to look at the protons and neutrons when we're talking about the mass of the atom. So now let's get to the box on the periodic table. So you will always see the symbols, and it's usually 1 or 2 letters. It matters how you capitalize them. I cannot emphasize that enough. It matters how you capitalize them. So the first letter of the symbol will always be capitalized. If there is a second letter, it will always be lowercase. It really does matter. Just trust me. I know where we're headed. It matters. So then there's all these numbers on the box. So what makes one element different from another? So if I'm looking at nitrogen and I'm looking at oxygen, why are they 2 separate things on the periodic table? Well, the difference is the number of protons. That is the most important thing about an element, because that's what makes one element different from another. I could have a million bajillion nitrogen atoms. Every single one of them would have 7 protons, because if they had more or less, they wouldn't be nitrogen. Same thing with oxygen. If I have 8 protons, it's oxygen. If it's any other number, it cannot be oxygen. So that number, the number of protons, is our atomic number because that's what defines those elements on the periodic table. So we're going to use gold here, AU, through a lot of the slides just to keep consistency. So gold's atomic number is 79, which means it would have 79 protons because that's what atomic number means. Now we need to talk about electrons. Well, in general, an atom usually has no charge. It's made of positively charged protons, it's made of negatively charged electrons, but they're going to cancel each other out. So the number of positives has to equal the number of negatives. So if I know that gold has 79 protons, then I know that it has 79 electrons. And then the second number on the periodic table, that's your mass number. That is looking at the mass of the atom. So we said we don't talk about electrons when we're talking about the mass of an atom. So this is just the number of protons and neutrons that you find inside of that atom. So we know how to figure out protons. We know how to figure out electrons. Now we need to figure out neutrons. Well, if our mass number is the total protons and neutrons, and our atomic number is the total number of protons, then if I subtract those two numbers, the protons will go away, and it leaves me with the number of neutrons. So here, I've done the math for you. So gold's mass number is 196.97, which we're rounding to 197. I'll explain why in a little bit. So we're taking the 197 and we're subtracting the 79 protons that are also there. So our answer in this case would be 118 neutrons. So if my mass number is 197, why isn't 197 on there? Well, that's because there are different gold atoms out there. They all have 79 protons because that's what makes them gold. But they actually differ in their number of neutrons, which means that the masses kind of vary a little bit. So this number that's actually on the periodic table is called the average atomic mass because it's an average. Let's say you're thinking about test averages and you make a 95, 95, 95, 95, 95, 95, and 100. Well, your average is going to be 95 and a little bit, maybe like 95.5. It's an average of all those different numbers, just like this is an average of all the different masses of gold atoms out there. So the big takeaways from today is knowing how to look at the periodic table and tell me the number of protons. Remember, that's going to be your atomic number. To know the number of electrons, remember that's also going to be the atomic number because those positives and negatives have to cancel each other out. And then the number of neutrons, you're always going to round. Always, always. Do not give me decimals for neutrons. It's a particle. You can't have 4.7 neutrons. That's impossible. So you're going to take that atomic mass, you're going to round it to the nearest whole number, and then you're going to subtract your atomic number.